Good morning, everyone.
Good morning, sir.
Morning. All right. So let's continue with the kind of problems we were doing last time. We'll do one integral problem and then I'll send some questions to you. We'll solve them together. Yeah. Good morning, Omkar. All right. Look at this. I've got what a sphere. All right. Some force F0 is applied along the diameter of the sphere horizontally in gravity-free space. So I've got a sphere of density rho, volume mass density rho. Okay. Now required to find, I'll make a section of it required to find force with which this section is pulling this section. Let the mass be m, all right? Mass be m, and density is rho, radius is r naught. So if density is rho, rho is equal to mass by volume 4 by 3 pi r cube. This is what we know. Again, let's talk about the physics of the problem. It's very simple. All I have to do is draw the FBD of this one, draw the FBD of this one. Acceleration is a naught. Right. So, and what else is there? That's it. Now I can write equation for this. Let the tension be T or the pull be T. Pull with which this part is pulling this one is T. So this will pull this part with T again. Action reaction pair. So I can write F is equal to T is equal to mass of this one. That is, let's say mx. Mx into A naught, where A naught is net external force by total mass. Right? That's it. That's the physics of the problem. But now all I have to do is plug in mx here. See, there is no formula for mx because it is a sphere. Volume of the whole sphere is 4 by 3 pi r cube. But volume of section of the sphere, there's no formula, fresh formula for that. For that, we need to integrate. All right. So
Yes, sir.
that's the math of the problem now. Yeah. So physics in T is equal to mass into acceleration రాశాను. మాస్ ప్లగ్ చేస్తే నాకు టెన్షన్ వచ్చేస్తుంది. టెన్షన్ as a function of x వచ్చేస్తుంది. Let's say this is x. This is r naught. So don't be scared looking at the integrals now. చాలా సింపుల్ ఫిజిక్స్ కదా. దీనికి ఎఫ్బిటి రాశాను, దీనికి ఎఫ్బిటి రాశాను. నాకు టెన్షన్ కావాలి, టెన్షన్ ఈజ్ కూడా మాస్ ఇంటూ యాక్సలరేషన్ రాశాను. యాక్సలరేషన్ ఇస్ వాట్ ఎఫ్ బై ఎం అది రాశాను. సో ఆల్ హావ్ టు డూ ఇస్ ప్లగ్ ఇన్ మాస్. ఎంఎక్స్ నాకు ఇచ్చేస్తే నేను ఆన్సర్ వచ్చినట్టు ఆన్సర్ అయిపోయింది. బట్ టు ఫైండ్ ఎంఎక్స్ హావ్ టు ఇంటిగ్రేట్. సో లెట్ us ఫైండ్ ఎంఎక్స్ నౌ. Look at this. We find volume of this part which is circular in section. All right, this is a sphere like this. This is distance x. This radius is r. What I do, I section the sphere. Look at the procedure. All right. Now we are doing basic math again. What we have done in basic math, I'm just redoing it. అప్పుడు చేసిందే ఇప్పుడు మళ్ళీ చేస్తున్నాను. If at all you have missed that over there, you can understand it now. If you have understood over there, it becomes very easy now. So I section the sphere into slices like this. I consider this each slice. I find the volume of each slice. I sum up all the slices. So I section this into infinite number of infinitesimal slices. I write the volume of small slice, that infinitesimal slice. I sum up all the slices. That's integrated. I get the volume. Let's see how do I do it. So at a distance of x, at a distance of tau, x already use చేసాను కాబట్టి tau రాస్తున్నాను. At a distance of tau, I'll consider a thin disk of width d tau. దాని రేడియస్ ఎంత ఉంటుంది? r square minus tau square under root.
R. Yes, sir.
Right. So r square minus tau square under root is the radius of that. What is the volume of that? Area into thickness. Volume of the disk. Thin disk కదా, ఆ డిస్క్ ఇలా ఉంది కదా, d tau area A. Area A d tau, thickness d
A
tau.
naught into dx.
That's it. A naught into d tau. A naught ఎంత ఉంటుంది? 5r square. 5r square into d tau. I integrate this from ఇక్కడ నుంచి ఎక్కడి వరకు? I have to cover the whole of the volume. Now my volume goes from this coordinate to this coordinate. ఈ coordinate ఎంత ఉంది? Minus r naught.
మైనస్
R
వన్
minus R naught.
Right side coordinate ఎంత ఉంది? X ఉంది. X వరకే ఉంది కదా. My slice is sectioned at x.
Yes, sir.
So minus r naught to x is my volume of this one. Now volume into density will give me mass. This volume into density will give me mass.
How, sir?
Density is equal to mass by volume కదా. Density is equal to
Yes,
mass
sir.
by volume. So mass is equal to density into volume.
Yes, sir.
So volume వచ్చేసింది. That into density rho naught is my mass mx.
Yes, sir.
ఇప్పుడు మాస్ వచ్చేసింది. టెన్షన్ ఏముంటుంది? టెన్షన్ Tx is equal to mass into acceleration, where acceleration is already found out as F by
F naught by M.
m naught. F naught by m naught. That's it. That's my answer. ఇప్పుడు దీన్ని ఇంటిగ్రేట్ చేయాలి. దీన్ని ఇంటిగ్రేట్ చేయడం చాలా ఈజీ. చూడండి, ఇది రూట్ ఆఫ్ హోల్ స్క్వేర్ కదా, సో రూట్ గోస్ ఆఫ్. All right, root and square get cancelled out. So I've got pi r square minus tau square. What is pi r square d tau? Integral pi r square d tau is pi r square tau minus pi r square common తీసుకుంటే tau minus tau cube by 3. Tau square, integral tau square is
Yes,
tau cube by
sir.
3.
Tau cube by 3.
Right. Under limits minus r to r.
Minus R
Minus r
naught
to x.
to X.
Minus r to x. Sorry. ఇప్పుడు ఏం చేస్తాను? I substitute the limits into f naught by m. This is my tx. ఇప్పుడు లిమిట్ సబ్స్టిట్యూట్ చేసి చెప్పండి. రో నాట్ పై ఆర్ స్క్వేర్ ఎఫ్ నాట్ బై ఎం. ఎంని ఎలా రాస్తాను? రో నాట్ ఇంటూ 4/3 పై ఆర్ క్యూబ్ రాస్తాను. సో రో నాట్ గెట్స్ cancelled out, pi gets cancelled out, r naught square gets cancelled out. Now what remains is f naught by 3f naught by 4r into, I substitute the upper limit. Upper limit substitute చేసినప్పుడు ఏమొస్తుంది? x minus x cube by 3 minus lower limit substitute చేస్తారు. Minus r naught minus r naught cube by 3. ఇప్పుడు ఏమవుతుంది? This minus becomes plus and minus, this is plus, so this becomes r naught minus x.
సార్ ఎం నాట్ ని ఎట్లా రాసుకుంటా సార్?
m naught ని ఇలా రాశారు. m
ప్రీవియస్
naught is equal to 4 by 3 pi r cube. M naught by 4 by 3 pi r cube is rho naught. Density is equal to mass by volume.
ఎస్ సార్.
So mass is equal to density into volume. Volume of the sphere into 4 by 3 pi r cube.
4/3 పై ఎస్.
అట్లా రాస్తే pi r square క్యాన్సిల్ అయిపోయింది, రో క్యాన్సిల్ అయిపోయింది, ఒక r మిగిలింది, 4 by 3 మిగిలింది. So can you simplify this further and tell me what's the answer? What is the further x ఇంకా ఆ terms లో? This becomes plus. This also becomes plus and that becomes minus. So this becomes r naught plus x minus r naught cube plus x cube by 3. So this is my tension as a, this is my tension as a function of x.
ఎస్ సార్.
But surely, now think about one thing. If at all I ask you what is the tension due to the half part on the remaining half part, that is E part. So this will be m naught by 2. This will be m naught by 2. ఇక్కడ ఫోర్స్ ఎంత ఉంటుంది అడుగుతున్నాను. అది లాజికల్లీ చూస్తే ఎంత ఉంటుంది? f naught minus t ఇంకా t is equal to m naught by 2 into a. So m naught by 2 into a, f naught by m. M gets cancelled out, f naught by 2 ఉంటుంది. Right? So if I substitute x is equal to r by 2, I should get f by 2.
సార్ can you repeat this once again?
See, just to cross verify, I'm doing this one. హాఫ్ పార్ట్ వల్ల ఎంత ఉంటుంది? ఫోర్స్ f by 2 ఉంటుంది. ఎలా వచ్చింది నాకు? f minus t is equal to m by 2 into a, or t is equal to m by 2 into a. A is nothing but f naught by m naught. M naught gets cancelled out, f by 2 ఉంటుంది నా టెన్షన్ when half force with which the half part is pulling the remaining half part. కావాల్సింది ఈ part. But I have got this equation for general x. ఇప్పుడు x is equal to 0 పెట్టినప్పుడు, when I put x is equal to 0, I should get f by 2 as the answer.
Yes sir.
So let's see if we are getting it or not. X becomes 0. Okay, so this becomes r naught minus r naught cube by 3. This becomes 3 r naught minus r naught cube by 3. 3 gets cancelled out. You're supposed to get f naught by 2 students. ఇది నేను t x is equal to 0 substitute చేస్తే I should get tx to be f naught by 2. Alright? Will you check this as homework? Did you get the procedure? You integrate this again. ఇది అర్థమైంది కదా? I've written mx into acceleration. But mx ఎలా రాశాను? v into rho. v ఎలా రాశాను? ఇప్పుడు డిస్క్ తీసుకున్నా area into d tau. Area is pi r square into d tau is my volume dv. దాన్ని ఇంటిగ్రేట్ చేశాను minus r naught to x. Why am I doing from minus r naught to x? Because my coordinate goes from minus r naught to x, because x is the section where I've sectioned it. X is the place where I've sectioned it. So minus r naught to x. దీన్ని ఇంటిగ్రేట్ చేస్తాను. దిస్ ఇస్ pi r square deta ఉంటే pi r square tau వస్తుంది. pi r square tau square అంటే tau cube by 3 వస్తుంది. And the limits minus r naught to x. So I substitute everything, I'll get t as a function of x. Just to cross verify, I'm saying that when x is equal to 0, my t should be f naught by 2. So when I substitute t is equal to x is equal to 0 in this dx equation, I should get t is equal to f naught by 2. You check that as homework. All right. I'll send some questions now. Did you receive the questions? Okay, good, Bhavna. Students, have you received the questions? Questions from Pichanu Ochea?
Yes, sir.
Okay. So let's go for the first question. MA, MB ఇచ్చారు, we have to find out MC. To find M naught so that they're in equilibrium. Look at this. I can combine these two as 3 kg block. Or I can also say 1g downward, 2g downward. Component of 1g along the plane is 1g sine theta, that is g by 2, plus 2g sine theta, that is g. Now this should be equal to m naught g, because force over here is m naught g. This force is counterbalanced by this downward force on the inclined plane, which is component of 2g and 1g along the inclined plane. This plus this should be equal to this. So I've got g gets cancelled out. M naught is equal to 3 by 2 kg, which is 1.5. Now he says, now with this 3 by 2, it's going to be in equilibrium. But now he says, second bit he says, what if the mass is double of this one, 3 by 2, double of 3 by 2, that is 3 kg. What is the acceleration of the blocks? So is it 3 by 2 కంటే 3 అది 3 ఉంటే ఏమవుతుంది? So let's see. We have done this. This is a
Sir,
look and say question. Yes.
sir, sir, it is
Uh-huh.
3G, sir. Acceleration.
Sure.
Sir,
Okay.
acceleration of A and B particles.
Acha.
3G.
See, acceleration of A will be same as B is same as C, right? Because they are connected with the same string. Considering this equation ఎలా ఉంటుంది? Acceleration of this is equal to this. This is equal to this. So ఇప్పుడు ఎలా ఉంటుంది? 3G minus supporting force minus opposing force. G by 2 minus G by total mass. Total mass ఎంత ఉంటుంది? 6. So my acceleration is 2G minus G by 2.
Additional.
G by 4. Check the answer. G by 4 correct. Am I correct in this calculation?
Like ఏం అనిపిస్తుంది?
Sorry? Three G minus G by 2 minus G by total mass. 3 plus 2 plus 1. 6. So 3G by 2. 3G by 2 by 6. 3 cancel, 3 and 6 cancel out by 3 1, 3 2, 6, 3 2, 6. G by 4. G by 4 is the answer. Is it correct?
Yes, sir.
All right. So G by 4 is the acceleration of each block. So this block is going upward to G by 4. This block comes down to G by 4. Look at the third pick. 19th question. Block of mass m is rests on the floor. At what acceleration with which should a boy of mass m climb along the rope of negligible mass so as to lift the block from the floor? I'll do this one. You try previous second pick as a homework. I'll do this now. So there's a block of mass m and a man of mass small m. M naught and m. See, he says, what should be the acceleration of this person along the rope such that this mass should not leave contact, right? So as to lift the block from the floor or just lift it. When this block just gets lifted up, normal reaction becomes zero. That's what he means to say. So normal reaction tells you 0 అవుతుందని. If that is not lifted up, let's say tension T undi, normal reaction N undi, gravitational force M naught G undi. So N plus T is equal to M naught G. When this just is lifted up, normal reaction becomes 0. So tension is equal to M naught G. N plus T is equal to M naught G. So when N equal to 0, now tension is equal to M naught G. So I got
Yes,
tension in the
sir.
string. I got tension in the string, which is acting on the man. So if I draw a video of the man, tension in the string is M naught G, gravitation force is mg, acceleration required is A. So I'll write mg minus, sorry, m naught g minus mg is equal to m into a. So I'll have m is equal to, he's asking acceleration, right? So acceleration is equal to m naught minus m by m into g.
మరి
The only point over here to be understood is when this gets lifted up, when this leaves the floor, normal reaction becomes zero. That is what he means to convey. In other words, he has conveyed that normal reaction is becoming zero when he's going up with an acceleration a. Instead of saying that, he said, what should be the acceleration? So I should lift the block from the floor. Lift the block from the floor అంటే normal reaction zero అయిపోతుంది. Just lift అయితే ఇది lift కాలేదనుకోండి, if he goes with the acceleration less than this acceleration, he cannot lift the block. But if this person goes with an acceleration more than this acceleration, this block will get lifted up. At exactly this acceleration, block normal reaction exactly becomes zero, so block just gets lifted up. If the person goes with this acceleration, the block just gets lifted up and the normal reaction becomes zero. All right, is it okay? All I've done is FBD. I've drawn the FBD properly for both the blocks. For this block, I've drawn n plus t is equal to mg, n is equal to 0, so t is equal to m naught g. I got tension in the string. I use this tension in the string over here. It is being pulled up with m naught g. Downward force is mg. M naught g minus mg is equal to mass into acceleration is the F is equal to ma. Acceleration of this is 0. Acceleration of this is a naught. So this is the equation a naught equal to m naught minus m by m into g. Is it okay, students?
yes sir.
Look at the eighth one. Next pick, eighth one. M and M. All right. Required to find acceleration of the blocks. Now tell me one thing. If the acceleration of this m is a naught, what is the acceleration or let's say if the acceleration of this is a naught, what is the acceleration of this mass m?
2n.
Sure.
Yes sir.
How can you say that? Push pull method చేసారా, fully method చేసారా, రెండు చేసారా?
So push pull method sir.
Okay. If I push this by x, string staggers by 2x, this moves by 2x. So x, 2x. A naught, 2a naught. That's right. Perfect. Fully method చూస్తే this is a naught, this is 0, this is ax plus 0 by 2 is a naught, ax is equal to 2a naught. Fine. Now, if tension in this string is T, this is T, this is T, this will be 2T because pulley is massless. Now, FBD of the bigger block, capital M. Equation will be F naught minus 2T is equal to M into A naught. I got one equation. Now equation of the smaller block M. T. T is equal to small m into 2a. I multiply this with 2 and add these two. 2t gets cancelled out. F naught is equal to m plus 4m into a. So a naught is equal to f naught by 4m plus m. I got acceleration of the bigger block. Acceleration of the lower block will be twice of this one.
Good.
I'll just fill the ink. If you've got any doubt, you please think.
ఎగ్జామ్స్ ఉన్నాయి.
Any doubt over here?
No, sir.
Okay, look at the ninth question. It's a constraint motion equation. Speed of the block B icharu, speed of the pulley Y icharu. We have to find the speed of the block A. X, pulley Y, pulley Z, block A, block B. Block B is going up with velocity of 1 meter per second. Pulley Y is going up with the velocity of 2 meters per second. Required to find the velocity of block A. Block A velocity kavalante, I need velocity of this point and velocity of this point. If this is B, this is 0. If this is 1, this will be 2.
Yes, sir.
Right? If this is 1, upward, if this is 0, this will be 2 because this plus this by 2 is 1. So this will be 2. Velocity of this point is velocity of point 1, 2, 3, and 4. Velocity of point 2 is 2. If velocity of point 2 is 2, velocity of point 3 would be 2 plus x by 2 is equal to 2. 2 plus x
2, sir.
by 2 is
Velocity
equal
of
to 2.
2, sir. Actually.
2? Alright, good. Faster. 2.
velocity of A becomes 0.
Okay. So if this is 2, this comes out with 2. 2 minus 2 by 2 is 0. Right. That's 0. So A remains at rest. Look at the 16th question. Next pick 16th one. Did you try that? 16th one, did you try? This is M. This is 2M. If this goes with an acceleration of A naught, what is the acceleration of this M?
Two
Right. That's right. Who is it?
Bhavna.
Okay. Yeah, that's right, Bhavna. If it's A naught, that's 2A naught. And if this is T, if this tension is T, this is T, this is T, this is 2T. So if I draw the FBD of upper block, I'll have 2T, 2M, 2T is equal to 2M into A naught. If I draw the FBD of the lower block, T, mg, mg minus T is equal to M into 2A naught. I multiply this equation with 2. I add these two equations. 2T gets cancelled out. So 2mg is equal to 6m into A naught. M gets cancelled out. I'll have A naught is equal to g by 3. If this is g by 3, this is 2g by 3. Similarly, along the same lines, you do the next problem. B
Sir,
bit. Yes.
అక్కడ 2m into 2a is 4ma not కదా సార్
ఇక్కడ కూడా 2m ఉంది కదా, రెండు ఈక్వేషన్స్ యాడ్
కింద
చేస్తున్నారు.
కింద
ఇది
ఓకే
4m
ఓకే
naught,
రైట్ సార్ రైట్ అర్థమైంది
4m naught plus 2m naught, 6m naught.
ఎస్ సార్
బ్లాక్ ఏ అనేది
Sorry?
రెడ్ మూవ్ అయితే బ్లాక్ ఏ 2M
బ్లాక్ ఏ నా ఏది
రైట్
ఏది
అనేది సార్
ఇది ఏ ఇది బి.
దాని మాస్ ఎక్కువ ఉంది కదా సార్ 2M అని
అయితే
బ్లాక్ మాస్ ఎక్కువ ఉంది
మాస్ ఎక్కువ ఉంటే
సరే రెడ్ మూవ్ అవుతుంది
ఐ డెంట్ గెట్ యూ. వాట్ ఇస్ ఇట్ భావన, వాట్ ఆర్ యూ ఆస్కింగ్? వాయిస్ బ్రేక్ అవుతుంది.
లెఫ్ట్ కి మూవ్ అవుతుంది కదా సార్ 2M అనే బ్లాక్
ఇది హారిజాంటల్ ఉంది కదా, దిస్ హారిజాంటల్. ఇక్కడ ఏం ఫోర్స్ లేదు, ఫోర్స్ ఇస్ ఓన్లీ టువర్డ్స్ రైట్. సో రైట్ వర్డ్ వెళ్తుంది అది. ఇక్కడ ఏం ఫోర్స్ లేదు కదా, లెఫ్ట్ వర్డ్ ఫోర్స్ ఏం లేదు. ఇది ఒకవేళ వర్టికల్ ఉంటే దెన్ థింగ్స్ వుడ్ హావ్ బీన్ డిఫరెంట్. బట్ హారిజాంటల్ ఉంది, సో రైట్ వర్డ్ ఫోర్స్ ఉంది, సో ఇది రైట్ కి వెళ్ళాలి, ఇది కిందికి రావాలి. I don't know if I answered your question, but your voice is breaking, so I couldn't get your question properly. Students, we're going to do pseudo force tomorrow. It's very important. Please do not miss. నేను ఇలా చెప్పినప్పుడు ఖచ్చితంగా మిస్ చేస్తున్నారు. నేను మిస్ చేయొద్దంటే ఖచ్చితంగా మిస్ చేస్తున్నారు. Alright, tomorrow we're going to do pseudo force. If you get time, please read about pseudo force and come back. Okay, let's try the next one. Inclined plane load. Similar, same 2M block, but it's on inclined plane now. The angle given. Given as theta. So again, I'll first get the constant equation. If this moves with the acceleration a naught, this comes down with an acceleration of
2
2a naught. Yeah, that's right. Now, again, I'll draw the FBD of the blocks. FBD of that block will be, if the tension is T, this tension is 2T, right? Because pulley is massless. So I'll draw the FBD of the lower block, M, tension T, mg. I'll presume that is going down. I don't know which is going down, which is going up. All right, I'll presume that is going down. mg minus T is equal to M into 2a naught. For this inclined plane block, 2T minus 2mg sin theta. So 2T minus 2mg sin theta is equal to 2m into a naught. I multiply this equation with 2 and I add these two. So 2t gets cancelled out. I'll have 2mg into 1 minus sin theta is equal to 6m into a. M gets cancelled out. That becomes a naught is equal to g into 1 minus sin theta by 3. I got a naught. 2a naught will be double of this one. Now look at the students. When theta becomes 0, sin theta becomes, sin 0 is 0, I'll get g by 3. That's what I got before. Previous case lo kuda ade vachindi now. Constant equation of a naught and 2a naught, and this was horizontal. When this was horizontal, I got acceleration as g by 3. ఇంతకుముందు g by 3 వచ్చింది కదా, g by 3 2g by 3 వచ్చింది. But now when it is inclined, it is 1 minus sin theta by 3. Look at this. I'm getting this is always positive. That means this will definitely come down. No matter what theta is, this is going to come down. Surely, 1 minus sin theta is always less than 1. For theta to be acute, sin theta is less than 1. When theta is acute, sin theta is less than 1. 1 minus less than 1 is greater than 1. Greater than 0, sorry. So a naught is greater than 0. So presumed acceleration direction kinda తీసుకున్నాను. I'm getting it to be greater than 0. That means my acceleration is, presumption is correct. అది కిందకి వెళ్తుంది. So no matter what theta is, theta 45 na 30 degrees na, this is going to go down itself. That I can conclude from the equation. He has not asked, but we can conclude. Okay, now let's go for the next one. C part. This is 2m. Now tell me, if this is A naught, what is the acceleration of this block?
A not by 2.
A naught
Sorry?
by 2, sir.
Yes, that's good. I was a little scared that you will tell me the wrong answer, but you have given me the right answer. Good. Thank you. I'm happy. All right. So it's A naught by 2. That's perfect. If this is A naught, this is A naught by 2. If this is T, this is 2T. So it is 2T. So my equation will be mg minus 2T is equal to m into A by 2. For this inclined one, it is 2mg sine theta or T minus 2mg sine theta is equal to 2m into A naught. I multiply this equation with 2. Add these two equations. 2t gets cancelled out. So I'll have mg into 1 minus 4 sine theta
4 sine theta
is equal to 4m 4a plus a by 2. That's how much? 7a by 2. Right? No, 8a by 2. 9a by 2. 9m a by 2.
Yes, sir.
So m gets cancelled out. So my acceleration will be 2g into 1 minus 4 sine theta by 9.
9.
Now look at this, students. This is 4 sine theta. So this can be greater than 0, this can be less than 0 also. So for certain angle, it can come down. For certain angle, it will go up. For certain angle, it will remain there itself. So let us see for what angle it will remain there. ఇది 4 వస్తుందా? Right, that's right. 4. So if acceleration is 0, that means it's in equilibrium. This force is counterbalanced by this force. ఈ force ఎంత ఉంటుంది? So if it is 0, sin inverse 1 by 4 is the angle at which they are in equilibrium. If the angle is less than that, this will come down. If the angle is more than that, this will come down. Acceleration negative వస్తుంది నాకు. Acceleration negative వచ్చిందంటే presumed direction కంటే opposite direction లో ఉంది particle. Particle is moving in the opposite direction to the presumed direction. That's what negative acceleration means. All right.
Yes, sir.
Any doubts you have got? Constraint లో అయినా or equations లో అయినా FBD లో? All right. I'm not drawing normal reaction here because normal reaction is counterbalanced by mg cos theta. Okay. So I'm not considering that. But FBD లో అది కూడా వేయాలి. Complete FBD should have all the forces. All the real forces should have. I mean, all the forces should have in an FBD. Whether it's real or false force, real or pseudo force, should have all the forces. But normal reaction I'm not drawing to save time. Because normal reaction is not contributing to the motion. Normal reaction is perpendicular to the motion only. So normal reaction component along the motion 0 only. So it's not contributing to the motion. So that's why I'm not drawing it. All right.
సార్ ఆన్సర్ రైట్ అని ఇట్లా తెలుసుకోవాలి సార్.
ఓకే, నేను ఆన్సర్స్ కూడా పంపిస్తాను ఇప్పుడు నుంచి.
నో సార్,
Alright.
అలా కాదు.
Huh?
ఐ మీన్ వెరిఫికేషన్ లాగా ఏమైనా అలా ఉందా అని.
That's what you're asking, Bhavna.
ఎస్ సార్, మీరు ఇవన్నీ దాకా చెప్పింది కదా సార్, ఇది రైటే అని మీరు
So verification ఏదైనా ఉందనా?
ఎస్ సార్.
Okay. No, that we cannot do in this case because we don't have any other way to conclude this one. ఇంకొక వే ఉందనుకోండి, then we can say that okay, ఇది చేయొచ్చు. ఎలా ఏం చేయొచ్చు? I can find out the equilibrium position of this one. I'll get theta for equilibrium position. That theta should correspond to A equal to 0 in this case. నాకు sin inverse 1/4 ఇక్కడ నుంచి వస్తే then my equations are right. But I don't have another way to come to this problem, come to this solution, come to this conclusion. So verify చేయడానికి లేదు. 2 ways ఉంటే నేను ఒక వేతో ఇంకో వేతో వెరిఫై చేసుకోవచ్చు. But here I've got only one method. ఓకే, అర్థమైంది కదా?
I think, sir,
Yeah.
I think భావన ఇంతకు ముందు మీ స్టార్టింగ్ క్వశ్చన్ లో డౌన్వర్డ్స్ వెళ్తుందని చెప్పారు కదా. అప్పుడు A0 ఏమో G/3 వచ్చింది. దాని నెక్స్ట్ ప్రాబ్లమ్ లో G/1 - sin θ/3 వచ్చింది కదా. అది
అవును.
మీరు కరెక్ట్ గా ఎలా అజ్యూమ్ చేస్తారని అడుగుతున్నాను. డౌన్వర్డ్స్ అని మీరు అన్నారు కదా, కరెక్ట్ గా అజ్యూమ్ చేస్తాను, అందుకే ఇది రైట్ అంది, ఇప్పుడు అది డౌన్వర్డ్స్ వెళ్తుందని అలా అడుగుతున్నాను.
Okay. See, downwards, I've taken downward to be my acceleration to be downwards. I got acceleration as positive. That means my presumed direction is correct. If the acceleration were turning out to be negative, that means my particle will go up. Presumed direction కంటే ఆపోజిట్ వెళ్తుంది. ఇప్పుడు నాకు ఇంతకు ముందు ఏమొచ్చింది? G/1 - sin θ/3 వచ్చింది. Now this is always greater than 0.
Yes, sir.
That means my presumed direction is always correct. That means particle is always coming down. ఈ పార్టికల్ కిందకి ఎప్పుడు రాదు. In the previous case లో, this inclined plane particle will always go up. There's no condition, there's no situation when this will accelerate down. ఏ యాంగిల్ అయినా, no matter what the angle is. బట్ ఇక్కడ యాంగిల్ చేంజ్ అయితే my acceleration can change the sign. ఒక యాంగిల్ కి పాజిటివ్ ఉంటుంది, ఒక యాంగిల్ కి నెగటివ్ వస్తుంది. Because 4 sin theta ఉంది. So there is a chance that this can be less than 0, equal to 0, greater than 0. సో ఇక్కడ రివర్స్ చేయడానికి
Yes,
ఛాన్స్ ఉంది,
sir.
అక్కడ లేదని చెప్పారు. That's the additional
Okay,
information we
sir.
talked about.
సో భావన డౌట్ అదేనా కాదు ఒకసారి అడిగేది.
Was that your doubt, Bhavna? Vignesh wanted to know whether same. Was
Yes,
it
sir.
same?
Yes, sir.
All right. Is your doubt clarified, Bhavna?
Yes, sir.
Okay. Okay, so there are 2 problems left. I want you to find the constant equation for the last one and try the second pick, 6.16. All right, try these 2 as homework. Just think చేయండి. Think చేయడానికి you don't have to sit separately and think కదా. You can think while now you can think. After the class you can think. While doing some work also you can think. Just read the question carefully and keep thinking about it. All right. So that's all for today, students. We'll continue tomorrow and we'll do pseudo force tomorrow. Please do not miss the class tomorrow. All right. ఒకవేళ మిస్ అయితే please continue with the recorded session. Recorded session చేసి మరి కంటిన్యూ చేయండి. All right. Do not continue the class without going for recorded session because we're going to use pseudo force in the next class. Day after tomorrow we'll use pseudo force. So tomorrow I'm going to teach you pseudo force, problems on pseudo force as well. All right. Try not to miss the class. Thank you all, students. Bye everyone. Have a great day.
Thank you, sir.
Bye.